All right, I think we should get started. All right, well, thanks for joining everybody. Good to see you. Just a few announcements before we jump into Aaron's presentation. So as you might have overheard, we're doing a little bit of fall planning. So thanks for everybody who joined last week. We had a great conversation. I'm gonna try to put together a final list of questions and concerns to send over to the SPE leadership by next week. So I'll just pop in the chat the collection of items we've put together so far. So if anybody has anything they want to add or edit by tomorrow, that would be great. Another quick announcement too is that USL faculty fellow Deborah McCrory Anderson is looking for someone to help her with a web project over the summer. So I'll forward it around some details via Slack, but let me know if you have any questions. She's just looking for a little bit of help with her GitHub project. And it could be kind of a fun summer project for some folks. And then Claudia and I developed some new Zoom backgrounds, right? So I'll share a folder of different kinds of backgrounds we put together. Would love to get your guys' feedback. We've been having some issues with pixelation and the mirroring effect that happens, you know, when it kind of turns it backwards when you upload things. You see what time. So we're trying to troubleshoot that a little bit, but let us know the ones that you guys like the best, and we'll try to circulate those around.
You can get it. It's $19.99 though.
Should be upside down so you do your yoga pose while watching it.
Yes. And then a couple of announcements about folks coming in and out of the lab. So this will be Max's last week before he heads off to summer, and he's going to be doing a special project for Resilience Quarterly all about land trusts, community land trusts, which is going to be exciting through the month of June. And then taking over for Max will be Emma Jane Geisler, who's been an editor for Resilience Quarterly. So she'll join us in the next couple of weeks to help out over the summertime. So I'll send an introduction around Slack and email. But thanks for Max. You're always a part of the family. Max. Yes, made the issue 2 happen for us.
Yeah, thank you, everybody. It was great.
It's been great having you on the team.
And you might see one other person join the lab this summer through a special Moan Fellowship. A person named Wes Thomason, who will be a research assistant helping out Louise Ahmed and Yoan on some synthetic infrastructure projects. So they're likely to start towards the end of May, but I'll send around some details so you can meet them and welcome them into the lab. Great, I think that's about it. So our final meeting before we take a summer recess will be May 27th in 2 weeks. And so we'll round out the calendar with a presentation from Anna Fiziak, who's going to talk to us a little bit about her project in the Rockaways. So hopefully you can join for that as well. Great. All right. Hey, Claudia, any announcements or thoughts before we jump in? Great. So I'm going to hand it over to Aaron Hill, one of our faculty fellows and a Parsons data viz assistant professor. He's going to talk to us a little bit about his work on uncertainty and maybe other things too. Thanks, Aaron, for being here.
Great, thank you. Just want to make sure you can hear me okay and that you can see the shared screen.
Yep.
Yes,
great.
Doing good.
Just move this and present. There we go. Okay, great. Thank you for having me. I'm gonna first talk just pretty broadly about the work that I do on uncertainty in data visualization. And then I want to get to something very specific as it relates to USL and hopefully lean on some of you for some subject matter expertise that I don't have. Broadly, expressing uncertainty in data visualization, let me just start with a couple of definitions. And I really love this one. Uncertainty as experienced by the individual is the joint product of environmental unpredictability and the actor's epistemic limitations. And I just really like how it considers each individual person as part of the uncertainty and what an individual brings to the table. And it's not just the unpredictability, it's also about what a given person might know and understand. So in the news, of course, this week and last is the latest jobs report, which unfortunately was a little bit on the disappointing side, but I wanted to draw on that to show an example of why I'm very interested in expressing uncertainty visually. So the April report has us up by 266,000 jobs in April, and the unemployment rate is at about 6.1%. And I'm sure you've all seen this, and these figures are reported widely, but what isn't reported as widely is the uncertainty under those numbers. So if you dig much deeper into the Bureau's report on it, you learn that their estimates are at a 90% level of confidence. And that means that the estimates can actually vary quite a lot, even though we're hyper-focused on that number of 266,000. If you get really into the weeds, and I'm not going to read this, but I'll share the slides and you can get into it if you want. But the confidence interval on that estimate is actually quite wide, even at a 90% level of confidence. So if we were to edit that 266,000 becomes 156,000 to 376,000, which is quite a lot of uncertainty, especially when you consider that even then there's only a 90% chance that the real number is within that estimate. So really there's quite, as focused as we get on that specific number, there's actually quite a lot of uncertainty in the number of it. It's in the number itself, and that has a lot of consequences. So and the Bureau is fantastic about being really transparent about this and communicating this. And so mathematically, we have the ability to estimate these things and be really specific about the levels of uncertainty and take that into account. So my interest, though, is in ways that we can express that visually. So there are wonderful mathematical and statistical methods. They're widely accepted. They're widely understood. But visually, there's not, unfortunately, the same level of standards and transparency. And so my work, and there are lots of others working on this as well, fortunately, is about standard visual representations, so that and for me, I'm most interested in the layperson. So the layperson can really get a sense for the uncertainty of the number without having to have expertise in statistical methods. So now just a quick definition of data visualization is Johanna Drucker's, which I love. Information graphics are based on abstractions, and there I have the emphasis on abstractions. Statistical data, all information visualizations are metrics expressed as graphics. They're always interpretations. Data does not have an inherent visual form that merely gives rise to a graphic expression. And so I love that, front and center, we're really talking about abstractions here. And of course, numbers are abstractions as well. But in these abstractions, can we build in the level to which they are abstract? Can we also communicate what we don't know about what we do know? So she goes on to talk about the legibility and simplicity. Just an example here, the graphics in aviation now are stunning and absolutely amazing in what's happened in even just the last few years. Here's an example of a screen view in a primary display that shows terrain in real time. And although it's very accurate, you can see that there is a level of aggregation that's happening in the terrain representations, because to have hyper-specific terrain representations would require way more processing power than a typical computer can be expected to use. And so they have to kind of cut corners. So is this a perfectly accurate representation of this terrain? No, it's not. Is it close enough that it can safely communicate what you need to know about the terrain? Absolutely. I especially love this little part here where, this is just not a typical shape of terrain, but it does give us just kind of the sense of what we do need to know, even though there's a lot of specificity that's been aggregated and abstracted away. So this is done a lot statistically and mathematically. It's not done nearly as often visually. And so why is it? Why is that? And you know, one of the things that I acknowledge is that it's just a difficult thing to do. So it's not done because people are trying to suppress the uncertainty or not acknowledge the uncertainty, but it's just actually a surprisingly difficult thing to do. So a couple of key reasons for that. One is that it adds a layer, it adds a dimension to the visual. So here's the simplest possible visualization where on the left, we're just looking at a single point in Cartesian space. And on the right is a representation of that simple point, which is just error bars or confidence interval around that point, which is perfectly easy to do. But what happens when you have tens of thousands or millions of points? And so you can't really, it doesn't really scale to that level of specificity. Commonly now there is that level of specificity in data. We just have more data than ever, and so adding that one layer on so many data points can render the visualization unusable. The other reason, I think this is really the primary reason, is that probability and statistics are just difficult to understand for the layperson, and we can't have high expectations around that. This is a figure from a really interesting 2005 study that was on PhD psychologists who specialize in statistical methods. And they were shown this figure with 2 points, one for group 1 and the other for group 2, with the confidence interval for each of those points. And they were asked to move the point and interval for group 2 to where it would need to be for the difference between the two groups to be statistically significant. So again, these are PhD psychologists who specialize in statistics and should mostly get this answer right. And unfortunately, the answers were far, far, far off. So here we're looking at the distributions of, so here's the correct answer, by the way. And here is the distribution of answers that people gave. So maybe far, far, far off is a little bit of an exaggeration, but you can see that mostly people had the error bars a good bit farther apart than they should be in order for them to be just statistically significant. And so the takeaway from this is that even among people who have a really deep understanding of statistical methods, there are still widespread misunderstandings of things like error bars and confidence intervals, which is a little bit of a shame because that's the primary way of visualizing uncertainty. So in the scientific visualization community, there are 3 primary ways that they think about showing the uncertainty in underlying data. The first is a probability density function where you just show the density of the probability, usually in the form of a histogram. And so here we have not only the point estimates, but we have the distribution of possible error on those estimates. So you can see where they are different, but close enough that they're not really different versus things that are so far off that even given the uncertainty, you know that these things are inherently different. So that's the first of 3, probability density function. The second one is to just show multi-value data. So this is a visualization of hurricane forecasts for the track of a hurricane. And we're looking at about a few hundred results of forecasts. And so if you just plot them over the other, you can see where most of the forecasts go, but you can also see that some of them really even almost kind of turn around and go the other way. So those are really unlikely, but they are possible. And by using the overlay, you can see, all right, well, here's the most probable location for the hurricane to go, but we can see that there are other scenarios that actually deviate quite a bit from the typical path. So that's the second, to just kind of show all of the possibilities. And then the third is to present it as bounded data, which I think is the most common. So there's that, there are those confidence intervals, again, on the right. And sticking with hurricanes on the left, we see the cone of uncertainty, which represents the 67% level of confidence of where the hurricane's actually going to end up. So 67% chance it's going to be somewhere in here, and of course a third chance that it's actually not going to be. But in an effort to recharacterize these categories a little bit, I like to reinterpret them through a design lens to think about methods that might be more intuitive and more clear and just a little bit more visceral, particularly for the layperson. So I like to reinterpret the bounded representations as blur and decay and erosion. And so if there is some sort of boundary, and we know that there's uncertainty around that boundary, to show that literally, or well, it's an abstraction, but to show that so that there's a much stronger sense that we don't really have a precise grasp of where that boundary ends and begins, but we have some general idea of that boundary. Reinterpreting the probability density function, I like to think of that as a spatial problem. I think people understand spaces much better than they understand probability density functions, and they're really kind of the same thing. And so are there paradigms where we can offer a spatial abstraction that doesn't rely on the consumer of the visualization to understand even what a probability density function is? And then I like to reinterpret multi-value as kind of a multiversal, lots of possible outcomes, and maybe even like a multiverse of possibility. So related to really the last two, the spatial and the multi-value, this graph really illustration by Tim Urban, which was out around the start of the pandemic. And it really left a huge impression on me and has inspired the work that I've been doing, where, just sort of generally, you're born and there are lots of different life paths that you could go on, but many of those are now closed off. So for me, maybe this is the one where I became an astronaut, but now it's way too late for that, and that's not going to happen. But from the life path that I happen to be on, there are still lots of different directions my life could go in, or anyone's life could go in. And around the same time that I saw this, I read this great book, The Midnight Library, which is the protagonist has a chance to kind of live all of these other lives as they would have been. And it's a great fun read, and it got me into just the right space to be thinking about, well, how could we, for the layperson particularly, how could we better convey all of these other possibilities that that still kind of fit within the realm of what's most probable. So you do understand things about what we don't know, but also about what we do know. And so in thinking about, all right, well, how does that going to translate to helping people understand this multiverse? There's a fantastic study in 2014 where subjects were at a computer screen, and over just a few seconds, they saw 100 numbers. They were all integers, I think 1 to 10. And these 100 numbers just kind of flashed by one after the other. So it kind of looked like this. So 100 of these where the number 2 or any other integer under 10 flashes by. And after they've seen all of these numbers pass by, they were then given this interface to say, okay, could you now remembering the numbers that you just saw flash by, could you now put them into the right bins? So put the right number of ones and twos and threes and so on up to 10. And what they found was that people were shockingly good when given this tool at reconstructing what is essentially a histogram of the numbers that just flew by. And in fact, they were better at that than if they had just been given the histogram to interpret. And I think this is a really amazing finding because it gives us a little bit of freedom to say, all right, well, maybe we can just show people more than we thought we could show people. And so maybe people have the cognitive ability to just kind of see lots of different outcomes at once that fit within some probability distribution, but without even having to talk about the probability distribution, we show them samples from that, and then we can, whether they have the statistical background or not, we can safely assume that they can kind of take that in and build a mental model of what that distribution would be. So I think this is a great finding and frees us to get a little bit away from the more rigid statistical representations that, yes, are accurate, but also don't seem to reach people in the same visceral way, and also don't seem to reach people quite as accurately. So one of the things that I've been working on, I've been calling it the visual bootstrap. Just a very basic example here is, so say you have a mean and that mean has some uncertainty around it. And we know what that uncertainty is. And so typically we would just show that mean, which is what the gray bar represents here. But what I'm proposing is instead of showing that specific point estimate, to actually take that away altogether. So here I'm just showing it as a reference point, but to just show the mean moving around where it is most likely to be. So here you can see that this is a measure that doesn't really matter, but here you can see it stays pretty close to somewhere between 37 and 38, and it never really deviates from that a lot. Because there's little uncertainty around this, it rarely deviates from the mean, and you can kind of see that in a way that you don't see if you're just looking at the mean for sure, and you really might not even see even if you look at the probability density function. And so the idea of the visual bootstrap is to take away this gray bar, take away this histogram, and just show the mean as it's moving around within that expected distribution, which may occasionally be really wildly off from the mean, but that's information that they can take in and understand that, all right, well, it does wildly deviate from the mean, but it's so rare that I can trust this, or it's so often that I can't trust that. And so then that brings me to the application that I've been working on my sabbatical, which is relative to sea level, and more specifically, sea level changes as climate changes. And so there's a great article in the Washington Post a couple weeks ago specifically about the uncertainty in those estimates of sea level change over time. It's mostly focused on the year 2100, but it's a great summary of the various estimates and really how kind of shockingly different they are. I think in some, the estimates are pretty optimistic that, by 2100, we're really looking at maybe only an inch of change, and others that are saying that, if everything goes wrong, we could be talking about tens of feet of sea level change. And so what I would like to do is to bring the concept of the visual bootstrap to estimates of sea level change, and more specifically to show them on maps. So this surging seas risk zone map has been around for a really long time. I think think the first time I saw it was about 10 years ago. And what I like about it is that there's a slider and you can see for yourself by, if sea level were to rise 4 feet, then this is how red hook and goannas, this is how much more water they would have if the sea level rose by that much. And so you can see what happens if there's only 1 foot of change or 10 feet of change. And so it gives the end user some agency to determine, all right, well, based on what I think is going to happen, I can see for myself. So I'd like to actually extend this to take a little bit of that agency back, and instead of allowing for a slider, to use the visual bootstrap to take solid estimates and what we know about the uncertainty of those estimates and animate this so that people are seeing the distribution of most likely changes. So they would see, they get a sense for that mean, but they'd also get a sense for the extremes within that estimate as well, but also kind of see how often or seldom that those actually happen. So the subject matter expertise, I am definitely not an expert on climate change and sea level rise. And so I'm aggregating, the Washington Post article is very helpful, but I'm aggregating these estimates and trying to get deep enough into them that I can get to the standard errors or confidence intervals or however they present them, so that this wouldn't just be a random animation of different possibilities. It would be based on what the science is saying about that estimate and about the uncertainty of that estimate, so that people can reconstruct it by watching the animation. So I think I've taken my 15 minutes and I'll just stop here. Do we have a little time for Q&A and discussion?
Yes.
Great, okay.
That was fantastic. Thanks, Aaron.
Thanks.
So many interesting layers. Let's open it up to questions and feedback and questions. Does anybody want to kick off? Have any comments for Aaron to get us started?
I can go. This is so cool, and I love that you ended with flood risk, because there's definitely been previous conversations about how flood risk is communicated, and I would love to hear more or like keep chatting about that. But I think the first question that I have to this endeavor that you are embarked on is it's hard to visualize uncertainty. And I think that we have, at least I have personally witnessed this in a lot of people during COVID times, is the frustration that a lot of people, express when they are given uncertainty. So is it hard? Is the difficulty, or is the fact that people or society may not be willing to deal with uncertainty like part of the equation here, or is like, yeah, what is your take on that?
Yeah, so I've been working on this for about 10 years. And when I started, I felt like my role was the data pessimist, to try to get people to not believe data too much. And now I feel like I'm on completely the other side of that, to say, okay, we don't have to take a nihilist, things are awful, but we don't have to take a nihilistic view, and there is still some value there. And so now I feel like the role is more that, hey, there's uncertainty. After this last few years, we all know that quite well. But there's still something of value there, even though there is no exactitude, even though that's what we desire. But then also, another thing that I just find really fascinating about human nature is that this is a major problem. I think I've talked about this in previous meetings about avalanche risk. And people, the most deaths in avalanches actually happen when the risk is moderate, not when the risk is high, because when the risk is high, people understand that and stay away. When the risk is low, people understand that and go. But when the risk is moderate, people don't know what to do. So they go, and that's where most deaths actually occur, unfortunately. And so it's in that most ambiguous area that people really just are completely lost. And that makes, I think, this endeavor much more difficult, but because I mean, reading that Washington Post article, I think anyone could walk away from that saying, I think anyone could walk away from that really frustrated, because it basically said, we don't know. We know it's rising. We're almost certain about that. But you know, there's a big difference between 1 inch and tens of feet. And unless there's something I don't know about, that's kind of where we are. But again, there's still actually value in knowing that, and particularly as the estimates start to get better, there's value in knowing, well, okay, there is a risk of, say, tens of feet, but how rare is that? And if we can communicate how rare that is, then that can help people to get a better sense of, well, what's the point of central tendency there, and what decisions do we need to make based on that, knowing that it could still be wildly different from that. And even I think about the climate change deniers who take some ammunition from the fact that some of these estimates is really rare, but some of them, one possible outcome is that sea levels will lower. And so, but even though that's 1 out of a million chance, I think people kind of grasp onto that and say, well, see, sea levels aren't necessarily rising, they could even be falling. But if we can better communicate that distribution, and people could really see how rare that outcome in the forecast is, then I'm hopeful that that can go a long way toward giving people a sense for what direction this is going in, even though we can't get really specific. And so if the point estimates are all over the place, but we kind of show all of them as best we can, then the ideal is it would be like those flashing numbers that we can see, all right, well, here's where it's kind of generally, and maybe that will make us feel better about what's happening, even though there's still tons of uncertainty around it.
Aaron, this was great to have such a refreshing look at uncertainty. I always study it from a point of view of politics and not really from a statistical perspective. But your presentation ended in a way that it made me feel like it was a great movie and I wanted to watch more. How are you thinking about applying this visual bootstrap to represent this uncertainty in sea level rise? Because I see how how is it that it works when you have hundreds of data points to see this bouncing bootstrap? Like how are you envisioning it?
Yeah, so the bootstrap part of that term comes from the statistical bootstrap, which is a way of estimating the uncertainty and error when you don't have the typical or traditional estimates. And so for reasons that I've never been able to understand, and I think most people don't understand, is that by implementing the bootstrap, which is just to resample with replacement, doing that almost always leads to an accurate representation of that uncertainty, even if you don't have those measures of uncertainty. And it's counterintuitive because it's such a simple thing where you're just taking you're just pulling point estimates from an ever-changing sample, and the sample itself doesn't change, but it just changes because you're replacing those values. And so unlike most other sampling, you can sample individual values multiple times. And in doing that, that leads you to the same place as if you had kind of the more robust measures of uncertainty. I don't think anybody really understands why that happens to be, but it has been demonstrated that it is, in most cases, just as effective as having those more robust measures. And so the thing that I'm up against right now is trying to get as many estimates of sea level change as possible. And ideally, when there are when there's transparency around it, to also get the estimates of standard deviation or standard error. And then the more of those I have, then the more we can pull, or that I can pull from that, and then just show those. And so ultimately, there could be millions of estimates, but if those are drawn randomly, then I think a consumer could just sit there and watch it until they got tired of doing so. And so as long as they stayed for a good 20 or 30 seconds, they would probably get a pretty accurate sense of what that distribution is. But the longer they stay, the more likely they are to see those extremely anomalous forecasts, and kind of understand how frequently or infrequently they might occur.
Just to maybe run with that in terms of adding a dimension. I mean, you made that clear, very glass clear in terms of adding that dimension. In this case, you're going to explore this over the time series. And so what's so important and fascinating is also this coupling to kind of cognition and psychology with your collaboration with Michael, and kind of that reach of what's possible when you have these kind of numbers flashing by. And I posted this really hilarious videos of chimpanzees being much better at it than any human could be, picking up the 0 and 9s. But it's basically a smoking gun in terms of being able to play back these actual number distributions. And I go immediately now to spectrum and audio spectrum analysis for this, because as soon as I go there and I start even maybe rambling about it, you can sense of that spectrum being visual, being played back as a sawtooth animation, playing back quickly until it gets so fast that it's a percussion, right? And so you have suddenly the idea, okay, what if we could play back at any rate? Let's say from half a frame rate to 2000 if we wanted to really show this kind of flood diagrams at any rate. So basically animation, which is your new added dimension, is in full control and can be chosen, can be played with, so that the attention span of 20, 30 seconds becomes this, mutable thing that you can say, okay, now play them all at once. Again, you have this, and you got them all again. And or you wait it all out and you have this million sample points. And with that, I'm getting super excited and sort of getting into computation and what the GPU does for us now with kind of LiDAR points and all of these things. So it's a little bit future forward for me, applying animation to spatial data, but this is essentially where I see this going in very exciting ways, and where, at some point, probably D3 and these kinds of graphs might, make way of other playback mechanisms of showing animations that are spatial, that are fluid, that are fast and slow. And we have another UI problem now. How do we play back? But it's that added dimension at any point. So I'm just wanting to go there with you with this audio spectrum, because this audio spectrum analyzers are around for decades and they're awesome. And once you start playing with them, they're actually intuitive, and I can use it, although I'm not a musician, and it's so much fun. So I hope that we get there with spatial data as well.
Yeah, it's such a good point. If one of the primary problems is that we don't have dimensions left for uncertainty, then if we can assign, whether it's the uncertainty dimension or some other dimension to make space for the uncertainty, then I enthusiastically agree that now more than ever, we have the ability, whether it's through animation or the other senses, to clear up some space. I mean, a lot of these the bounded, particularly the error bars and confidence intervals, were constructed at a time when people published only to black and white journals. And so we've got a lot more, but it's funny how old habits die hard. And so we're still putting confidence intervals on everything. But we really do have more dimensions than ever for communicating a lot of other things. And so there's not much of an excuse left for not conveying the uncertainty, but it's hard to do. Just that the Bureau of Labor Statistics estimate, even though we have all of these measures, still everyone is talking about that 266,000 jobs and talking about it as though it is the law of the land. And it's probably quite close. It's probably quite close, but it's definitely not exact, and it could be way, way off.
Aaron, have you played around with sort of letting uncertainty be revealed or not? What I mean is, one of the things I was interested in Pablo's comment is sort of thinking about how some people want to see the uncertainty and some don't.
Mm-hmm.
And I think there's a spectrum there. Maybe the majority don't. So, right, you were saying, oh, early on, you're like, want to force it on people to some extent, but I'm curious if you've played around visually with various kinds of methods to allow you to sort of ignore the uncertainty when you want to see a central trend. So it comes out very strongly, so you can get that message, and then at the same time, allow yourself to dig into the uncertainty. And I think you've been talking a lot about a couple different kinds of climate signals that have various kinds of uncertainty, and in some cases there's more than one kind of uncertainty operating simultaneously, right? Like these projections around sea level rise, there's uncertainty in any individual projection, right? But then there's multiple scenarios, which is where you get these huge ranges, right? Because it's like how many different if-then statements are part of any one of those. So there's more than one kind of uncertainty operating in any range that you might be given between an inch and a foot or a foot and a meter, right? So I'm kind of curious about whether you've played around with ways to allow yourself to kind of dig deeper sequentially and back out and basically allow people to kind of choose their own adventure and how much they want to know. Because I feel like I see one or the other. I either see like a line, you're supposed to believe it's real, or you're given information that people don't know how to deal with.
Yeah, I have such mixed feelings about that. Just harping on that Bureau of Labor Statistics estimate of 266,000, that's very economical. Like you can just really, and without having to say much, you communicate a lot. However, you give up the ability to say, basically, well, 266,000, give or take. And so if you only show the estimate without the uncertainty, you have that economy that is extremely valuable. But you also you also are putting a lot more weight on its shoulders than it really can bear. And so I think personally, I would rather the default be an expression that encapsulates the uncertainty that you could turn off if you wanted to. I don't know if any of you remember or follow the New York Times a lot in any election, the needle of uncertainty, which caused all kinds of confusion and also was pretty controversial because this needle that moved around to kind of try to show the uncertainty of the estimate, people thought that was real-time data coming in. They didn't realize that it was just an estimate to show, instead of saying, all right, so-and-so has 45% of the vote, to show that, all right, it's around here somewhere, but people saw that and thought, oh, this must be the real data coming in right now, when it was really just a single estimate and the uncertainty of that. So I can see the value of all sides of it, the economy and the ease of communicating. If you focus on the point estimate, but also the misleading nature, or somewhat misleading nature of, well, what's really kind of going on under that. But I think it's very, I think what's been so great about what computing has done for data visualization is you can just put a lot of agency in the users, or return a lot of agency to them. So things aren't as editorial, they're more participatory. And I think generally that's a wonderful thing, and that people should have as much agency as they want. And if that means, hey, let's turn off this needle and just look at the estimate, then I think people should be able to do that. And so then the question is, well, what is the default? And I guess also part of that, though, is, all right, if people are misunderstanding this needle, then we shouldn't maybe be using a needle, or we have to find a way to educate people what this needle really means. And so, or we need a more visceral representation that people are going to kind of get and not have to guess at what that is. So I think it's great if it's great if we find a default view that people get, and but also give them that ability to kind of, all right, let's focus in on that estimate, and I'll do my own uncertainty thinking about where this should be going.
Pablo, did you have a response or question?
Yeah, I'm sorry, I just find this fascinating. But I'm just building up on time on, and what you just said about giving agency to the user. I can't help but think about whether there is a responsibility from the data visualizer or the producer of the visualization on giving the opportunity to the user or the recipient to choose what uncertainty they feel comfortable with. And I'm thinking about, we have here this flood risk map, and we're excited about representing visual, like spatial uncertainty, but how will that translate into a person choosing where to build their home if perhaps, they get to a place that say that they deem that a certain, like what you were showing, that hurricane itinerary, graph, and showing, well, it's very unlikely, but it's possible that the hurricane turns around and goes down to the Gulf of Mexico. So do you think that will enable more precautionary decisions from users, saying like, oh, damn, like this is actually a likely scenario that I would not have seen in the cone of probability, hence I'm going to take precautionary measures? Or will that lead to more people saying like, it's 20%, that's not that much?
Yeah. Well, so a couple things. One is that, and this is also related to Timon's question as well, around the multiple types of uncertainty. And one of the things I really love about the statistical bootstrap that I'm kind of repurposing and just changing the final step to show it instead of summarize it, is that it's also really good at representing multiple types of uncertainty, including the types that aren't typically represented. And so I like that it's just a much wider view of uncertainty, and it's almost purely by accident. It seems to represent those uncertainties really well. And so the more sample points you have in there, the better it's going to be at getting at all of those different types of uncertainty, not just the ones that are statistically important, like what's going on in the sampling distribution. It's all kinds of other great things like missing values and biases and other things. And so I feel particularly optimistic about the bootstrap generally, because it's just, it really casts the net really much wider than it's normally cast through the more kind of official and more robust measures. And then on the hurricane, I think John's here, right? John, are you here?
I'm here.
Yeah. So John and I are working on, he's the lead author on a paper that we're working on right now, specifically about hurricane maps, because those are notoriously misunderstood. And so people look at that. Let me go back to the, where was that? So people look at that, that cone of uncertainty, and an alarming number of people think that that's about the size of the hurricane and not about the bounds of where they think it's most likely to end up. And even since studying it, I've learned a lot of things. And I grew up in a hurricane area, and I didn't know that it was a 67% confidence interval. I always thought it was a 95% confidence interval. And there's some great papers that we could point you to about how people just really misunderstand this. And so much so that it's almost, it's almost negligent to be continuing to use it. And so in our paper, we're looking at some other ways of just kind of more simply representing that risk and getting right to the point, and not having people, or not asking people to have to interpret all these different parts of this kind of representation. But it is, you bring up the possibility that the hurricane can stop in its tracks and turn around, and that's really, really rare. But I do think that poses its own set of challenges, even letting people know, even reminding people of that possibility, because again, with sea level change, all right, if we model this once in a blue moon, there will be a reduction in sea level instead of a rise in sea level. And so, if people have that information, what are they meant to do with it? And so I think if we're going to show it, then the visualizer has a responsibility to make really clear the context of how rare that actually is. And again, I think I feel pretty optimistic about the bootstrap for this, because if you're watching even really just a few seconds of it, you ought to take away from it, how really rare it would be for that kind of thing to happen. But the truth is that it's within the realm of possibility, and I wonder if that would gain some trust as well. Because if we're just more transparent about what we don't know about what we do know, could that help in building trust, because we're acknowledging that there are multiple possibilities here, but also helping people really understand what is the most likely, or at least the neighborhood of the most likely outcomes.
Thanks, Aaron. This is really interesting. I have a kind of very specific question that's based on applying bootstrap to flooding. And that's, people are used to looking at kind of two things. One is sea level rise over time, and they're used to seeing that shoreline, corrode. And we're also used to tide maps, or at least I'm relatively used to thinking of tidal mechanisms in terms of ebb and flowing. So if you're going to be running bootstrap fluctuations, if I'm understanding correctly, is kind of showing that uncertainty at any given moment by having the sea, take part of the city and then recede back into the ocean. Depending on the context, like if this is something that's just embedded within a piece and someone's just scrolling, how visually do you communicate that this is not over time, that this is in a given moment? Because it seems like we're all kind of programmed already to think that way. Maybe the title thing is less relevant, but it also just seems like just very specific to that instance. And then the second question, which is kind of more speculative, is I could see a really interesting application for what you're doing to be looking at specific environmental justice implications of interventions. So if you take an Army Corps proposal and you say this is the fail mechanisms that's built into it, it's not likely, but if this were to happen, these are the communities that would be exposed, and you can run those different situations through. I could see that being a really effective way to actually present like pressing public information in terms of decision making, how we decide, yeah, like how we decide whether something is safe or whether the design is inherently racist or inherently something else, by looking at that kind of, especially with what you said, which is actually really optimistic, that if you just see all these eventualities, we actually have a really accurate way of internalizing that. So two very different questions, but yeah, thank you so much for the presentation.
Yeah, no, thank you. That's a very helpful question, but also, you know, so climate change and sea level change, something I'm interested in and have zero expertise in. And so I really appreciate those kinds of questions and nudges, because I think it's an important thing to get really right. And I am far from expert on that. And it's such a great point about the timeline, because the way the only way I can imagine this working is if you do what the Washington Post did, and let's just pick the year 2100 and stay there and allow it to change there. And I hadn't really even contemplated, well, what if you have time as a dimension as well? And so that gets us back to Daniel's point, which is that, you know, we're definitely out of dimensions to map to. And so if we're adding time, then something else has to happen. And I suppose that animation could represent both of those, but then that starts to feel like too much to ask cognitively. And so there would have to be some other way. And I haven't given, unfortunately, I haven't given a lot of thought to what that way might be. And so I guess just my knee-jerk reaction to that would be allow people to choose a year and then see the animation, and so they could sort of do their own timeline. But also that seems a little lo-fi, so maybe, you know, maybe there's some other way of representing that time, but also allowing the animation to have. So that's a really good thing to consider, that I don't really have a good answer for right now. And then with you know, with what else could we use this for? I also share some optimism around, well, maybe not even just uncertainty. You know, maybe this is a better way of just generally communicating the results of forecasts, or kind of anything else that's sort of iterative and can have different possibilities. And even maybe just the kind of the typical decision tree, is maybe instead of going down all of those branches, we just show all of the leaves in some creative way that people could get a good sense of that without being really overwhelmed by it. And so I think that and the other, you know, the other thing is, so the real bootstrap, so the statistical bootstrap is now kind of in its mature age, where it's enough times been demonstrated that it's reliable and effective, and in some cases even really more effective than the traditional methods. I think there would be a lot of work to do to confirm that changing that last step to a visualization instead of an an aggregation is as accurate as I hypothesize it to be. So I think there's some work to do there, but even still, I think that that 2014 study has made such an impression on me, because for so long we've thought about constructs of that sort of space of possibility, and none of those really included, well, let's just bombard people with, because it sounds like that's not the kind of thing that would work. But it turns out there's evidence that actually people seem to take that, walk away from that with a much better understanding of the distribution than if we have some sort of aggregated construct of that distribution. So I do feel optimistic about other ways of showing these kinds of possibilities, whether it's numerical or even qualitatively. There are ways that things go in different directions. So but I will be very clear, it's a working hypothesis, and that there's still a lot of work to do to make sure that that this would actually hold up over time.
That's great. Thanks, Aaron. We're running a little short on time, but maybe to wrap things up, is there any specific, need or thing that the lab could help with? Any, more feedback that you'd like folks to target, or data or help in any kind of way, or moving forward?
Thank you, Chris. The primary thing is I'm just looking for as many estimates of specifically sea level change as I can get my hands on. And so the more I have, the better. It'd be great if someone knows of a meta-analysis or some sort of aggregation of all the disparate estimates. I just know so little about this area that I'm stumbling around in the dark a little bit. So if someone knows of a place or a repository or a paper meta-analysis that includes the variability in all of the estimates, that would be tremendously helpful.
And to clarify, are you looking specifically at New York, Aaron, or the US, or globally?
I think, I had really been pretty New York centric about it, but I don't know why, actually. So I'm really interested in other areas as well. So yeah, let's cast the net really, really wide there.
Any other thoughts before we wrap up for Aaron?
Just to, I don't think Luis is on the call, right? Aaron, you should just send Luis a Slack message with that exact question, because we've been working on a couple things where we're looking at repositories of sea level rise data, and so there's different things out there, but he'll faster, more quickly grab a link for you that might be useful.
Perfect. Thank you so much.
Thanks again, Aaron, for your time. This is wonderful. Looking forward to seeing maybe some prototypes in the fall, or just any developments would be so great. Yes.
Great. Thank you.
Thanks, Aaron.
Great. So we'll see you all in the next 2 weeks, the 27th. We'll hear from Anna to wrap up the spring session, everybody. So great to see everyone.
Great. Have a good evening, all.
Have a good evening. Bye, everyone.